Welcome back, Math 3. Here we go. We got our hosts here helping you. Welcome back. Welcome back. Where we are working on our square roots. And our cube roots. And so we are going to triple factor these. Yeah. So something times something is 40. Let's go. So we're first going to break it just into two of them. So let's do like what? 10 times 4. And then that can break down into 2 times 5 times what? 2 times 2 times 2. That's right. And so we have 3 numbers are the same. Can you see what they are? 2. Yeah. So we can circle 1, 2, 3 of those. We can circle 3 of those. And so the 5 has to stay inside, but the 2's can go ahead and come out. And so we have 3 cube roots, right? Cube roots, you guys. There we go. So we got the cube roots. What's left is the 5. And then the 1, 2, 3 of them can then, 1, 2, 3 of them can then pass through the cube roots and come out. So just be 1, 2 there. Now don't forget, there's still a negative in there. So then we have 3 times 2 is 6. 3 times 2 is 6. The negative comes out as well as a what? Actually, it comes out as just a negative, because negative times a negative times a negative. Negative times a negative times a negative is a negative.
Because a negative times a negative is a positive, and a negative times a positive is a negative.
Yeah. Yeah.
Oh, yeah.
So that's our answer. So then we have 64. And 64, what's the square root of 64? Square root of 64 is 8.
Yeah.
What about the negative? What does the negative become?
Positive.
Imaginary imaginary jai. And then we divide it by 4. Everybody, 8 divided by 4 is 2. So we have a 2i. Right? We have a 2i. Don't forget that 81 and 36 can be reduced. And you can actually do them separately, is my hint to you.
Yeah.
And then don't forget to reduce it more.
9/6.
Whoa, that's right. Yeah. So then we have, they have to do the even ones. So here's the odd one, number 15, which is beautiful.
Yeah.
And 17 is even more pretty, maybe not. Okay, well, here we go. So then we're going to go ahead and, that's a square root still, So we're looking for pairs.
Ooh.
5, 5, 5.
Where's the
Another 5, we got another 5.
What the?
You have y to the 7. So why did I say 5s? I have no clue. So those are actually x's. And then how many y's do we have? 3, 4, 5, 6, 7.
What the?
There's so many. 32. What does 32 break down into? 8 times 4.
Yeah.
So what about a perfect square? So that's 16. Times 2 could also be thought of, right? So 16 times 2 is also 32. And the reason why I jumped to the 16
It's because then you can split.
is the square root of 16, right? Is 4 times 4.
Yeah.
And you need a pair of those, and then one of them comes out. And also the square root of 16 is 4, right? Which is 24. And then, let's see how many pairs we have. How many pairs? We got 1, 2. So we got 2 pairs that come out. That's an x squared. And then 1, 2, 3 y's come out. That's a y cubed.
2, 3.
And so we're left with the square root of 2 and an x and a y. You guys like that answer?
Yeah!
Oh! It's crazy, just like you guys. Just like you guys. Okay. How does 216 work? Well, 6 times 6 times 6. Don't be superstitious.
Yeah!
It is 216. It's 216. The negative, because of the third power, the negative comes out. So if you have the square root of a negative, that's just I. But if you have the cube root of a negative, right? If you have the cube root of a negative, the cube root, then that's going to be just -1. So that's like a little note, so don't forget that little note there. Don't forget that note. Okay, beautiful. So then a 6 is indeed going to come out, and it's going to be a -6 that comes out. If you don't believe me, ask the dishes. They can sing, they can dance.
Yes, you can dance!
Beast. So the square, wait. The cube root of -216 is -6. -6.
Oh
yeah. How many do we have? We have x to the what? X to the third, x to the third, x to the third, x to the third. How many x to the thirds do we have? So that means that when you do the third root now, when you do the third root of x to the 12th power, it actually ends up being that there's 1 of them, 2 of them, 3 of them, 4 of them that come out. 3 of them that come out. 3 of them that come out.
That's all plus.
There's our answer.
Yeah!
What?
Yeah!
So try number 19. We'll do 19 as well, because 19 looks kind of tough.
Doug shape?
Let's see. So can we reduce 48 and 12?
Yeah!
What does that become?
4 and...
It is 4.
Yeah. 4 and 1!
Yeah.
4 and 1!
Right? 4 over 1. So we're left with x to the 6. We still have the square roots. So now we have the square root of 2 and the negative. So that's going to be able to pull an I out, as well as a 2.
Slicer!
So now, no slicer. Be careful. So then we have the 1 over x to the 6th power. Okay, so the square root of 1 is just 1. That's fine. But we have 3 of those. We have x squared, x squared, x squared. So we have 1, 2, 3 of those in there. So that's going to come out as 2x to the 3rd power I. Okay, you guys double check. Wait.
Let me check.
Wait. I think that's in the bottom. Okay, what do you guys think? Take a look
Let me
up
check.
here.
Oh, yeah, I think it's right,
Yeah, I think we want to keep them all positive. Okay, good job, you guys. Okay, last one. Last one, you guys, last one. What value of x makes the equation true? So I taught this to you last year.
Yeah!
How do we end the bases?
Yeah!
So log base 4 gets rid of base 4. So the bases can basically cancel. Right? If you have the same bases, they can cancel. If you have the same bases, they can cancel.
They can cancel!
So we have 3x minus 2 equals 13. And we're going to add 2 to the other side. So then we get 3x is equal to 15. Woo! Everybody! 15 divided by 3 is... 5! Which is C.
I can't wait for Newbold to give us the go-ahead.
Yeah. Ready? Say thanks, Mr. Newbold. 3, 2, 1.